Are you curious to see how AI trained the data for a given task? I'm here today with a beautiful web application, Neural Network Playground, which shows how AI training happens in step by step without a single line of code. It's completely free and work with your browser. Hello everyone and welcome to Kanai's AI, where we turn complex AI ideas into simple stories. Let's see the demonstration of Neural Network Playground. You can use this link for practicing. This might look a bit technical at first, but don't worry, I will try my best to make it simple. Let's start the demonstration. Here is the web platform. So we will be beginning with our data set, which is available on the left portion of the web application. So here is the option. As you know, in real time, the data may fall under different categories like spiral data, sometimes a linear separable data, sometimes a non-linear separable data, sometimes a cluster data. So imagine you are preparing an AI system to classify supermarket vegetable into fresh vegetable or rotten vegetable. Sometimes the original data can be clean like linear pattern, or sometimes it is going to be very messy data. So you can see two different colors also present in the data points. The colors like the oranges and the blue line. So we have two different categories. One is blue and another is orange. The blue and orange dots are our binary classes of image data points, where the blue represents one class and the orange represents the other class. The model job is very simple. Figure out where the dividing line goes, just like a linear or a non-linear line, to segment it into two different classes. You can try switching the data set into any method, either a spiral or a cluster or a linear or a non-linear. I'm keeping the data nature a spiral in this particular case. So let me go and select the data nature as spiral. So our data considered as a spiral nature now. Now you can also define your ratio of the data set here to train and test, where the training data goes for model training and the test data go for model prediction. And also you can assign the batch size to the model training. Also you can assign noise to the data to make more realistic. So I'm assigning batch size as 10 and noise as 10% and keeping the ratio of training to test data as 50%. With that, we are moving to another checkbox which is present exactly next to the data, which is called data features. We are into data features now. Let us see what are all present in the features functions. You can see there are x1, x2, as well as x1 square, x2 square, x1, x2, etc. These are all called features and the derived features, which is going as an input to the neural network. So the x1 square, x2 square, etc., the sine function, log function, which identify the non-linear relationship in the data. So we are going to select which are all the features we are going to use for this particular activity. So I'm selecting the features here x1, x2, x1 square. I am deselecting these two just for experimenting the same thing. Okay, so after that, on the right side, you will be able to see another setting called problem type. Let me see my problem type. So here is the setting for problem type. So we are going to define whether our problem is a classification problem or a regression problem based on the nature of the target. If the target is to predict the continuous value, then we choose regression. If it is to predict the predefined category class, then we choose classification. I'm setting here to a classification problem. So by default, this is into classification problem now. So after defining the problem, so we are going to create our neural network structure. As we are very clear, the neural network, the first layer, that input layer is data, and the last layer, which is a classification layer, which is a binary classification layer. I can see there are two neurons which represent the binary classification. Now we are taking our look to the center where the neural network lives. You can see here, this is our area we are going to do attention now. So the two neuron represents a binary class which goes as an output to the output layer. Now we can do add or removing the hidden layer to capture the pattern present in the image. We can see here whether we can add or remove the number of layers, as well as we can add the number of neurons in each layer like this. Let us keep trying with some settings. So you can increase the number of hidden layers. You can see the number of hidden layers are increased. Also, I am increasing or decreasing the number of neurons present in each and every layer of sequential architecture. So I just created an architecture like this. So this is my neural network architecture. So neurons are like a mini decision maker. Adding more and more hidden layers and neurons makes your model more complex to identify the complicated data patterns. Think of like teaching a child where adding more layer equal to deeper thinking. But same time, too many may get confused instead of understanding. So we need to keep a balance in between. So now above this network, you will be able to see another setting called learning rate, activation, regularization, and regularization rate. So we are going to identify one by one. So what is learning rate? Learning rate decides how fast the model updates itself. Too slow learning rates becomes the model too slow in terms of model training, and too high means learning rates makes into jump across and may out of focus. So we need to keep a balance of learning rate as well. So after that learning rate, there are something called activation function, which tells each neuron how to respond to the input receives. That is, activation functions moving to the next layer input of the next layer architecture. So you can select anything from this activation function. There are activation called ReLU, 10H, sigmoid or linear. So in general, ReLU is preferred. So 10H is preferred when the output needing between -1 to 1 range, and sigmoid for probabilistic values between 0 and 1. So I am going to select one by one in this particular case. So let me select the learning rate. I am keeping my learning rate as 0.01. And as I mentioned, from this list, out of ReLU, 10H, sigmoid, linear, I am going to select sigmoid as my activation function. And we have one more option, which is an add-on to help model preventing overfitting challenges. You can choose between L1 or L2. So I'm selecting L1. And also we are adjusting the strength of the overfitting, strength of the regularization, which is available in the slider. I'm just again keeping 0.01 as regularization rate. Now we are done with all the basic necessary settings. We can now hit the button available in this particular section. This is nothing but run button. So we need to watch closely, and you can see what's happening on the output side. So I'm just hitting the run button on the right side. So you can observe the output prediction is changing regularly. For a better model, the training and test loss is going to reduce, means that the accuracy of the prediction is going to increase. Maybe for this particular learning rate, maybe this particular sigmoid or regularization, the prediction may be not so good. So you have to keep experimenting it. So you can observe some misclassification. Of course, no models are 100% accurate. You have to play around with this application. So you need to change the dataset nature. Maybe you need to change the data ratio, batch size, and you need to experiment with the parameters like learning rate, activation, regularization rate. And if the problem belongs to regression, you have to change that as well. You can add more features. You can increase more hidden layers. You can increase or decrease the number of neurons in each and every layer architecture. All this can be changed to get a better model so that your prediction will be good. So keep experimenting. So I am just moving to the summary slide. So what is actually happened? The neural network playground is a perfect tool or an application for anyone who is an aspirant to the data and interested to explore neural network magic. So what do we learn from this particular? So we learn the parameters in AI model training. We learn how to visualize the neural network, and we are clear that for a small changes in parameters of the neural network can lead to a big improvement in the model performance. The best part, you did it without any code. So by the way, this tool is not a toy. This is a simple neural network written in JavaScript. So thanks to the creator for a truly awesome work. So hope you enjoyed the video throughout. Stay tuned with Kanai's ALA for more informative content, and don't forget to like, comment. So subscribe for more explainer and demonstration content with AI Lab with Kanai.